Annyeonghaseyo and welcome 8th graders to Geology 7. Today we are going to be talking about sedimentation. Sedimentation sounds kind of boring, but actually some pretty interesting things come out of it, like fossils. So hopefully that can pique your interest about our topic for today. Our entrance task is to take a look at this picture, tell me what it is, and tell me how it's formed. Just take a couple minutes and go ahead and write your answer down in your notebook. Hit pause, and after you write down your answer, go ahead and hit play again for the rest of the lesson. So our objectives for today. Content objective is to understand how deposition creates sedimentary rocks and fossils. Language objective is being able to describe the process of fossil creation. And I don't have any keywords for today, but I do have an important point. Question is like, oh, why is this important? This is important because fossils provide really important information about the history of our planet. And so if you want to learn about life going back millions and millions of years, the fossil record is extremely important. Okay, let's talk about erosion. Yesterday we were talking about erosion and sort of the different layers of rock that is exposed by erosion, but let's review quickly. So erosion, as we mentioned yesterday, is the movement of soil or rock caused by wind or running water. Here we have, I really enjoy this image, I really like this image. It shows different types of erosion. So on the top left-hand corner we see river carving out a valley. We see waves cutting back a cliff. Down below we see wind blowing topsoil. This is kind of the most disappointing part of the slide. Hoping for something a little bit more dramatic, but wind can also cause erosion, which is an important point they're making. Next, we have a glacier, which is kind of scraping up all kinds of dirt and rocks from the, I guess, area it's making contact with. We'll talk more about glaciers later. And lastly, we have an image of a landslide where a really large amount of land sort of collapses, falls, and piles up at the bottom of a hill or a mountain. I also wanted to show a different image of wind blowing topsoil. Like I said, that image that we have in here is just a little bit disappointing, but some very dramatic rock formations are caused by just the wind. So these are sandstone cliffs, and they're in a desert, and a lot of these sort of dramatic formations we found in deserts, and they're caused entirely by the action of the wind. It's not just the wind itself, it's usually wind blowing fine particles, and those fine particles, as they blow over eons, over like long stretches of geological time, will carve out these beautiful and dramatic landforms. Next, we're going to talk about deposition. And so deposition is related to erosion. So erosion happens in all those different forms that I showed earlier, but we're going to focus now on just basically rivers and streams carrying away little bits of material. So these dissolved bits of materials go through rivers and streams, and they end up in the water, and they end up settling in the water. And as they settle to the bottom, more and more layers of sediment kind of pile up on them. Now, this is called compaction. This is a really important idea because as more and more layers pile up, there's more and more pressure. That pressure increases, and what that does is it eventually squeezes water out of the bottommost layers. And then as even more layers pile up, that pressure increases, and what it eventually does is it squeezes those materials in the sediment into crystals. Basically the molecules in there sort of arrange into a regular form. You get crystals. That's called sedimentation. And what you get from sedimentation is sedimentary rocks. So sedimentary rocks, as mentioned before, are formed by deposition and compaction. You can find them everywhere. I'm sure all of you have seen sandstone in some form or another. It's a very common rock. Pick it up. You can kind of rub your fingers on it. It feels a little gritty. Anyways, these are sedimentary rocks. So the process in which sedimentary rocks are created is pretty much the same process in which fossils are created. But let's first of all pause for a moment and explain what a fossil is. So a fossil is the body of a living thing that gets I guess, replaced by rock. It's a pretty dramatic process. Usually when things become fossilized, all that's left is the bones. Sometimes you can see a little bit of outline of like some of their other tissues, but usually it's only the bones that become fossilized. Let's talk about this process in more detail. So, in order to make a fossil, you need a living thing, and that living thing must die. And after it dies, it must get buried by sediments. And sometimes these two steps, they're not separate. Sometimes they happen at the same time. I'll show you a couple pictures which illustrate this, but I'll do that later. Next, these sediments build up over time, and this is a process called compaction. So one sediment is laid down, and another goes on top, and another, so on and so forth. And then those layers get squeezed. And as the bottom layers get squeezed more and more from the weight that's on top of them, it eventually sort of presses all the water out of those materials. And eventually that pressure builds up as the sediments build up, and that pressure becomes so intense that the sediments themselves crystallize into rocks. And so here we have an image of step 1 and step 2 happening at the same time. This fish has swallowed another fish, and it got buried probably in some sort of landslide. It got covered in sediments, and we can kind of guess that this is what happened because we can see that sort of outline of both fishes' bodies. If they died and sat on the bottom of like a riverbed or a lake bed or even the ocean floor, different creatures would have ate the sort of flesh on their body, and they would not have left this outline. However, because this outline of their body is here, we know that the body, along with their bones, fossilized. And so we know something. This must have been some sort of sudden or rapid death. Probably died by a landslide. Probably the smaller fish was, I don't know, maybe trying to escape the landslide, and the bigger fish saw an opportunity for a meal, and that ended up killing it. Here is another image of a fossil that was created by a landslide. Again, step 1 and step 2 happening at the same time. This dramatic fossil came from Mongolia, and when you look at it, it almost kind of looks fake. It looks like it's staged, but it's actually real. And it's a fossil of what they call a protoceratops, which I guess is a relative of like a triceratops. Proto means like kind of early form, so maybe it's an early form of a triceratops. Nonetheless, this animal is fighting with another dinosaur, it's very famous, called a velociraptor. And as I'm sure all of you know, velociraptors have these sharp and terrible sort of razor hooks at the end of their feet, which they use to make terrible wounds on their enemies. This velociraptor has its hooks right in the neck of this protoceratops, but the protoceratops also has the arm of the velociraptor in its mouth, and it's broken in several places because it's got a really strong bite. Anyways, while these two were fighting, they were also buried in a landslide and sort of trapped forever in this position. So now we're going to talk a little bit more in detail about fossil formation. And I want to note as we begin that only a small number of living things can become fossils. This is a process that we feel like we understand pretty well, but it just takes such a long time that humans are not able to kind of create fossils themselves. The process of fossil creation probably takes thousands, if not tens of thousands of years. And so in this image, we have a crocodile that dies, and it dies in the bottom of a river. Sediments cover its body. Eventually, those sediments get compacted, and then they crystallize into rocks, and the skeleton of that alligator is now a fossil. And then some millions of years later, the rock erodes, and that fossil becomes exposed. So that's it for this class. I'm trying to keep things as short as possible. I don't want you to be spending too much time in front of the computer. Your homework is going to be very simple. All I want you to do is draw a picture of how something turns into a fossil. You'll probably want to look at the last slide to get some ideas. You'll probably do like a couple separate steps. But to just review, you have a living thing and it dies. It gets buried by sediment. Those sediments pile up, Okay, and then we have compaction, right? It squeezes all the water out of the body of that living thing, and in addition to all the sediments around it. And then finally, that pressure becomes so great that the sediments around that living thing and even the bones of that living thing crystallize into rock. So anyways, that is the process of turning into a fossil. Please illustrate that and send a picture to Schoology, upload it to Schoology, or you can send it directly to me at sjkwok@sageyoungacademy.org. If you have any questions, once again, hit me up during office hours. None of you 8th graders visit me during office hours. Hit me up during office hours. I'd like the company. Anyways, you can find me then every day, 9:30 a.m. to 10:30 a.m. And in addition to that, you can either send me or Mr. O any questions directly to us. My email is sjkwok@sageyoungacademy.org. Mr. O's email is hoh1@sageyoungacademy.org. Okay, thank you and peace.